Hello and welcome back to another LeetCode problem. We're looking at the next easy problem, LeetCode 3684, maximize sum of at most k distinct elements. By now you should know the drill. This is kind of an interview practice video, not an explainer video, where I try to go through the structured process during a coding interview. And so let's dive right into it. So first, let's understand the problem. So we are given a positive integer array nums and an integer k. Choose at most k elements from nums so that the sum is maximized. However, the chosen number must be distinct. Numbers must be distinct. Return an array containing the chosen numbers in strictly descending order. Interesting. Now, I want to know what the constraints are. Can nums be nil? Can it be empty? And what are the values inside of it? And constraints are listed here. So we can see that nums contains at least one element. We know that nums consists only of positive integers larger than 0. And that the integer k is going to be between 1 and the length of our array, inclusive, right? So this is first, yeah, okay. All right. So we must choose at most k elements. And, well, let's look at an example here, because it doesn't mention anywhere if the numbers are in sorted order or not. Apparently they aren't. And also the number range is large, so that we can't really just try numbers whether they're in there or not. So I guess what we'll have to do is we'll probably have to sort this, and then we pick from the largest on, we pick k element. Probably what we have to do. Okay, so yes, let's just look at an example real quick. So we see here, there's a list of numbers. We must choose the top 3 numbers, the largest 3 numbers. And we can see that those is 100, 93, and 90, right? Yeah. And we must return them in this order. Cool. And that's the output, that array. In the second example, we have 100, we have 93, but we have 93 twice. So we can't use it twice, but the next number is 84. Okay. That's an important edge case. And now here, what do we have here? We must choose at most 6 numbers, but we only have 2 distinct numbers, so we can only return 2, right? Okay, and the maximum sum is 3. It's interesting that it talks about maximum sum, but we never have to return the maximum sum. Cool. So I think we figured out how to solve this, right? If the numbers are in sorted order, we just pick the largest numbers and make sure that we don't pick any numbers twice. I think there are different ways of how we could approach this. So we could sort the array first, and maybe in non-increasing order, so that the largest elements are first. And then we start to iterate over the array. And yeah, and when we encounter a new number, we add that to our result, and we will skip over numbers that occur more than once. That's what we could do. And we make sure that that our result list never grows larger than k, and then we just return our result list. I think that is one approach. So that would be O of n log n for the sorting, but we still have to iterate over all of the numbers, which adds plus n, but O of n is smaller than O of n log n, so strictly speaking, in time. And well, in terms of space, well, in the worst case, k is equal to the length of the nums, and all elements are distinct, in which case we have to return the entire nums array. So we also need O of n base. So that would be one approach. I'm thinking of a different approach where maybe we first compute all the distinct numbers. I think that is what we could do as well. And then we perform the sorting only on the distinct numbers. So that would give us an O of n plus k log k time, where k is the number of distinct numbers, and O of k space. N is right length nums, k is number of distinct numbers in nums, which of course in the worst case is still n, But yeah, it could run faster on average, I suppose, if you assume that nums is a random array with random numbers. And what we could also do is we could, yeah, I think those are kind of the two different approaches. We could also use a heap queue if we wanted to sort the numbers or pull them out in sorted order. Also possible, but I don't think that will change the runtime. It's still going to be a k log k, where k is smaller or equal than n. So let's implement maybe the first solution and then the second one. In an interview, I would ask, okay, which one do you want me to implement? And they'll probably pick the later one because it's slightly more interesting, but let's implement both. So first we do nums.sort and reverse true. So that means we sort it in reverse order, starting at the largest number. And then, we have a little result array that we need to return. And we should initialize that maybe first. And now what we do is while we iterate over all of the numbers in nums, right? For n in nums. And we need to add, n to our result if n is different than the previous number, right? We have to keep track of the previous number. And in the beginning, it's nothing, right? So if not if, or actually we can just do the comparison. If n is not pre n, and this is guaranteed to be true for the first number, because none is not in our array, then we'll just add n to our result. And I think the numbers to pick, k is going to be at least 1, so we can safely append the number. And then we check if the length of a result is equal to k. Well, then we need to break out of our loop. We're done. We can't add any more elements. So then we return. And if we don't have enough elements to reach k elements, that's fine, right? As we saw in this example. Then we only return as many as we could pull out, iterating over all of the numbers. But of course, after this little check, I have to remember what was the current number n, so that I don't pick it again the next iteration of the loop. So I think that solution should work. I'll now run it through test cases down here. And reverse, so that's a typo, just reverse, not reversed. Right, and so that worked. Nice. Let's submit it to see if we pass all the tests. And we do. Oh, fantastic. Cool. So now let's try the other approach. And I said that we would first compute all the distinct elements so that we don't have to skip over elements that don't exist in an optimal case. So what we'll just do is, well, we could, in Python, you can do that quite easy. You just do set from nums, and now you have a set of numbers. And now what we'll do is we will create I think we can just do sorted nums again to create a list. If I'm not mistaken, I'm not 100% sure. But I think that should work. Well, we'll find out in a second here. So, and now we know all the numbers are distinct and they are in sorted order. And since this is an array, what we could also do, and we could also say reverse is true, or maybe I just want to be a little bit on the safe side here. I say nums is going to be a list of nums now, and now I just do nums.sort. Maybe I look up what I wanted to try earlier will work. And well, I could just return an array, because we already have an array of all the distinct numbers, and I need to make sure that I don't pick more elements than are available in the array, and I need to pick at most k. So I'm going to take the minimum of k and length of nums. And so that makes this solution much simpler. I'm just thinking if there's maybe an off by 1 error. No, I don't think so, because the end of the range is exclusive. So that should work. So let's try this. Kind of curious if that works. So here, what do we see? Object of num has no length. Oh, nums. Oh, because nums.sort returns none. Because you call sort is a function that is attached to the array. So you just call that to sort the elements, but it returns none. So if you assign it again, then whatever you assign it to becomes none. Cool. So that works for our test cases. Let's submit this now. Right. And so there it is. And actually, this implementation is much simpler than the one below here. But just because we use slicing of arrays here, and we do a very quick, transformation of nums into a list of distinct numbers, right? If we did this by hand, we could do this as well, but not necessary. So that concludes, this little interview practice.